It's exam time once again, time when your life revolves around studies. But if revising and re-revising is making your head spin, all you need to do is to take time out and watch Topper's exam special. Hi, I'm Arjun Bhagat and we'll make sure that this show gives you an edge over all your friends because together we'll trace exam trends and practice probable questions. Also, we'll give you some tips to do well in exams. Just remember, at Topper, we study smart. So put on your thinking caps and let's get started.
In today's episode, we're going to discuss a very important topic, matrices and determinants. I'm sure you already know that this topic belongs to the unit Algebra and accounts for 13 marks in the board exams. That's a whooping 13% of the total marks. But what you might not know is that starting 2008, CBSE has changed the marking scheme for this unit. The types of questions you can expect are very small answer types that are 1 marker or short answer types that are 4 markers. And watch out for those 6 markers. Out of the 7 6-mark problems in the question paper, 1 will be from this unit.
Knowing the trends is important, but there's no substitute to diligent revision. Let's refresh what you've already learned under this topic. So let's quickly recap.
Under the topic matrices and determinants, you would have learnt about identity matrix, equal matrices, multiplication of matrices, finding the transpose of a matrix, symmetric and skew-symmetric matrices, minors and cofactors of a matrix, and the properties of determinants.
I hope you've already gone through all these topics thoroughly. Now, before we start practicing questions, let me tell you the ability types that you'll be tested on.
In this chapter, you'll mostly be tested on your numerical ability. Some questions might even test your knowledge and conceptual ability. So broadly speaking, you will be tested on 3 abilities in this chapter: numerical, knowledge, and conceptual ability. Our in-depth research on exam trends has shown that this could include problems on properties of determinants and the system of linear equations. Also be prepared to face problems based on the algebra of matrices, on symmetric matrices, elementary operations on matrices, and finding cofactors.
That revision and the knowledge dip should have jogged your memory and warmed up those grey cells. Good for you, because coming up next is a question that is a prototype of what you can expect in the exams. So if you want to be a model student, then pay close attention to today's model question.
You must solve the system of equations using the matrix method. This is a 6-mark question that is typical of what you might be asked in the board exams. It is not a very difficult question, but what you need to watch out for is the stepwise marks distribution. Before you begin writing the solution, you must write the algebraic equations in standard form. That's easy. Here it is. Now, this can be written as ax is equal to b. Now, express this in matrix notation and write coefficient matrix, variable matrix, and constant matrix. I'd like to emphasize here that it's very important for you to clearly state the 3 matrices or else you lose marks. Another important step is to check whether the inverse of the coefficient matrix exists. Be very careful here because it's a step students often forget. When you calculate determinant A, check whether it's 0. Here it isn't. That means the inverse exists. Now, calculate the inverse of A by using the adjoint of the matrix. Be careful to write elements in correct positions while calculating the adjoint. Now, substitute the value of the inverse of A in the relation x equal to A inverse B. So the solution of the system of equations is x equal to -2, y equal to 1 and z equal to 2. And don't forget, before you end, you must write the answer in its usual format.
I must tell you that in this question, you have to be very careful about writing complete algebraic expressions, both before beginning the solution and then in the end as the answer. Besides this, you must, when dealing with matrices, be extremely vigilant about the order and positioning of elements. Remember, untidiness won't just put your examiner off, it'll also lead to incorrect calculations. So to impress your examiner, be tidy and correct. Take your room for example. If it is untidy, finding something in it is nightmarish. But when everything is organized, finding your stuff is so simple. This topic is very much like that. It is very easy to score if you take a systematic and orderly approach. With that knowledge tucked under our belts, let's go practice some more questions.
Our first practice question rates high on the difficulty meter. It was asked in 2007 and carried 3 marks. But this time round, it could be asked for 4 marks. You remember the multiplication of matrices, don't you? Because that's what this question is about. If A contains the elements 2, 3, -3 and 4 column-wise, show that A square minus 6A plus 17I is equal to 0, and hence find the inverse of matrix A. First, calculate A squared by multiplying the first row by the first column and the second row by the second column, without forgetting the accurate positioning. Following this, A square minus 6A can be written as given. Multiplying all the elements of the second matrix by 6, we have. Now find the values A square minus 6A. Substituting the values on the left side, we get a 0 matrix, which is equal to the right-hand side. Half the question is done, so you earn 1.5 marks. Now, let's get to the second part of the question. Find the inverse of matrix A. Let's use the given equation. Multiply both sides by the inverse of A and simplify it in such a way that apart from A inverse, all the other quantities are on the right side. Then, substitute the values and get the inverse of A. That'll earn you the remaining marks. Here you will not get marks if you find inverse using adjoint of matrix A.
Changing tracks from the multiplication of matrices, let's tackle a question based on elementary operation on matrices. If you recall, I'd said that this is a new addition in the syllabus and could be asked in the exam. So if you can crack this one, you'll definitely have the topper advantage.
This is a 4-mark conceptual ability question, which is considered difficult because you need to use the concepts learnt in class to solve tricky problems. In this case, you have to find the inverse of the given matrix A using elementary transformations. The first step is to write the given matrix as a product of the identity matrix and itself. So, substitute the value of the given matrix on the left and the identity matrix on the right. Now, using elementary row transformations, let's transform the matrix A on left-hand side to I and get I equal to AA inverse. At this point, be very careful to apply the transformation on the right side's identity matrix as well. It's a common mistake to omit this step and it can cost you precious marks. Now apply elementary row transformation in such a way that the last 2 elements of the first column are 0. Now make the second element of the last row 0. Finally, make other non-diagonal elements 0 and the remaining diagonal elements 1. We've now expressed the relation as I equal to A inverse A. Therefore, A inverse is given by. If this is the way you would have solved this problem, give yourselves full marks and a pat on your back from us.
We're at the halfway point in our practice session, so this would be a great time to revitalize ourselves before proceeding further. Up ahead, we have our remaining practice questions along with our red hot HOTS question. We also have a special topper treat for you, tips and advice to crack the exams. Right now, I'll leave you with this breaking question.
Construct a 2 into 2 matrix for A equal to aij. If aij equal to I plus j square by 2. Chew your pencils on this while I'll take a short break. Before the break, we asked you to construct a 2 by 2 matrix for A equal to aij if aij equal to I plus j square by 2. Now it's time to find the answer. As you can see, A is a matrix aij of order 2 into 2, where aij is I plus j square by 2. So, the elements for a matrix of 2 into 2 is given by A11, A12, A21 and A22. Now, let's find these elements by the given relation aij. We find that the required matrix A is 2, 9 by 2, 9 by 2, 8. Well done for getting this conceptual solution right.
Welcome back to our exam special on matrices and determinants. I'm Arjun, and so far we've been studying exam trends with a focus on matrices. Through our questions, we saw how important it was to position elements properly, include algebraic expressions in our answers, and remember definitions. And before you prepare yourself for your next question, I'd like to tell you the two most common mistakes students make while solving this sort of a question. One, forgetting to perform the transformations on both sides of the equation. Second, forgetting to write the final answer. You heard me right, so don't get so caught up in finding that solution that you omit the final answer.
Next, we have a 3-mark question from CBSE's 2006 question paper. On the difficulty meter, this question is average, so you shouldn't have much trouble answering it. Express the given matrix as the sum of a symmetric and skew-symmetric matrix. This question is based on knowledge ability. Again, it could be asked as a 4-mark question this year. As we know, every square matrix can be expressed as the sum of symmetric and skew-symmetric matrices. Here, half of A minus A transpose is the skew-symmetric part and half of A plus A transpose is the symmetric matrix. So we get the symmetric part as 1 upon 2 multiplied by matrix 2, minus 3, 1, minus 3, 16, 9, 1, 9, 10. And the skew-symmetric matrix as 1 upon 2 multiplied by matrix 0, 9, 9, minus 9, 0, -3, -9, 3, 0. If we look at the marks distribution, you get half a mark each for defining symmetric and skew-symmetric matrices, and 1 mark each for denoting the two parts of the given matrix.
Now let's move on to our next topic, determinants. Its properties are a very important subtopic, and we've found a question on them almost every single year in recent times. So the next practice question demands your absolute attention.
Let's take a look at one such question for 6 marks, which can also appear in the 4-mark category. Using properties of determinants, prove the following determinant is equal to 2 whole multiplied by a plus b plus c whole cube. This question is based on conceptual ability. The comprehension of properties of determinants is important to crack such problems. Your exam strategy for this topic must always consider the end result that we need to prove. Any property we apply will be determined by this end result. Also, while applying properties, try to take common numbers from the rows or columns for simplification. In this particular question, we make the elements of the first column equal so that they can be taken outside. This way, we get each element as 1 in the first column. Now, apply properties in such a way that the last 2 elements of the first column are 0. Again, I'd like to emphasize that before expansion, try to reduce as many elements to 0 for simplification. By following this step, you'll easily get the desired result 2 into a plus b plus c whole cube as verified.
I hope you found that first question on determinants easy to solve. When it comes to conceptual questions like that, one must never lose their nerve. Remember, the concepts are all known to you. They are at your service to help you earn topper marks. That wraps up our practice session on questions based on determinants, which, as you might have noticed, are a favorite with the examiners. So I can't stress enough how important it is to learn the properties of determinants thoroughly and practice, practice, practice and practice more. Because remember, there's no easier chapter to score 4 to 6 marks in. Well, if that's gotten you all warmed up, then it's time to go in for a HOTS question. These questions have been introduced by the CBSE to test high-order thinking skills on your part. So let's take a look.
If A and B are 2 matrices such that AB equal to B and BA equal to A, then find A square plus B square In this particular question, first consider A square as AA, B square as BB. Now use the given equations of AB equal to B and BA equal to A in the above equation. Using the associativity of matrix multiplication, we find that the required expression is equal to A plus B.
Remember that the principles HOTS questions are based on are the same as the regular questions. So keep your cool, read the question carefully, and I'm sure you'll get through with the solution. It's obvious from all that we've studied so far that you just can't afford to be lax in memorizing all the definitions and the properties of matrices and determinants. So why not log on to our website www.topperlearning.com for a comprehensive list, because if you can learn those facts well, that's half the battle won. Next up is a list of exam tips and advice that'll keep you way ahead of all the others.
The first and most important trick is to write solutions in an orderly fashion is essential in this topic. So write the elements in correct positions, especially while multiplying matrices. Don't forget to apply transformations on the right-hand side identity matrix. It's a common mistake, so please try and avoid it. Although this is a very simple chapter compared to the others, many students lose marks because they get overconfident and don't practice enough. Since this chapter is skill-based, please do as many sample questions possible. Do calculations carefully. When a question on determinants asks you to use properties, you must use them to get the final answer. If you don't use the properties, even a correct final answer will not earn you any marks. You must use at least 2 properties in your answer to get full marks.
That was our final tip for today as far as the chapters on matrices and determinants are concerned. On a personal note, I feel that one of the most important things students can take into the exam hall is a high level of confidence. As a wise saying goes, preparation tells you what to do, confidence allows you to do it. So stay positive, reach for the stars and make this your best exam ever. Take care and goodbye.